Okay, so integrating logarithmic functions. So here's some of the things. The big ones to think about. The integral of x to the -1 power is natural log of x plus c. And I really like to see this also as integral of 1 over x dx equals the natural log of the absolute value of x plus c. And the integral of natural log of x dx, this is a pretty interesting one, is x natural log of x minus x plus c. I'm not going to derive that for you here. That could be an office hour exercise if we want to do it, simply because it's going to take skills that we haven't learned yet. It is integration by parts, and you have to go back and do some equations and some algebra within the algebra. And then here's the last one. The integral of log base a, so it's not a base e, it's any base, is going to be x over natural log of that base times natural log of x minus 1 plus c. The point being, this is the same as the previous one if your base was e, because natural log of e is 1. Okay. But what's, to me, the most important one that you're going to come across, you have all these different power rule ones, x to the n, integrate that. If you have the integral of x to the n dx, you get x to the n plus 1 over n plus 1 plus c, except that's for n not equal to -1. This is the case right here for n equals -1. It gives you this natural log of absolute value of x. Okay. Can't stress this importance enough. So let's do a couple of these. I'm going to show you something really cool. So we have the integral of 3 over x minus 10 dx. What's the antiderivative going to be? We can do a U substitution if it's easier to see it that way. I don't know how necessary that is, but I'm not opposed to it in this case, at least to get things moving. So, I mean, you could treat this as 3 integral of 1 over x minus 10 dx. And if you want, you could say 10 equal or u equals x minus 10, and your du is just going to be your dx. This becomes 3 integral 1 over u du. So that's 3 times what? What did we just learn above? The integral of 1 over x dx. What was that going to be? Natural log of the absolute value of u plus c. And we had 3 times the natural log of the absolute value of x minus 10 plus c. And really, this is the answer I'd leave it with here. I mean, if you want to be really creative, you could make that 3. That's a coefficient for the natural log into a power for the x minus 10. If you remember your log rules from your pre-calculus days. The constraint we have is you can't be 0 in the denominator, so x cannot be 10. Now, there's the absolute value on the natural log, because natural log, you can never take it of a negative. It has to be positive. It can only be positive values. It can't even be 0. It has to be positive only. So that's why there's an absolute value on that. What I just did, but let's go ahead and look at, try this one now. You can do U substitution if you want. It's not going to make a big difference. It's just that term in the denominator, that's x plus 2, is going to go into what we're talking about. So what would you have? Go ahead and try this one. What would you have for this one? The integral of 1 over x plus 2 dx. What would that be? The idea is that's it. It's just natural log of the absolute value of that x plus 2 plus c. That's it. Now, use the U substitution if it helps. By all means, use it. That one, the last two, maybe not so necessary. If it was an x squared, I probably would have used it. There's another concerns if it was an x squared, but yeah, I probably would have used it, but something that was a little more simple, or if it was like a 3x plus 7, I might have used it. But in this case, because the derivative of x plus 2 is just 1. Okay, here's a more interesting one. Finding an antiderivative of the rational function 2x cubed plus 3x over x to the fourth plus 3x squared. So when I first saw this one, I got a little like, oh no, it's going to be heavy. And I just kept thinking, I'm like, well, we haven't seen partial fractions yet. That's not what they're talking about. I could factor that, but, and then I started thinking about a few other approaches to it. The numerator's got a smaller degree than the denominator. So this was an interesting test. I mean, if I were to look at the integral of 2x cubed plus 3x over x to the fourth plus 3x squared dx, if I look at that and I say, try u substitution. This one I definitely did try u substitution. I said, well, what if u equals at x to the fourth plus 3x squared? I had to think contextually, where are we? We're doing log antiderivatives of logs or things that produce natural logs. So I had to think, okay, if that was my u, what's my du there? What's the derivative of x to the fourth plus 3x squared? 4x to the third plus 6x. Now, can I factor something out of this 4x dx? Bless you. Can I factor something out of it to make it look like 2x cubed plus 3x? So you have a 2, bless you. So I can say that this is equal to 2 times 2x cubed plus 3x. Now this matches what I have here. So now I feel a lot better about this. I can say du equals 2 times this amount and dividing by 2, I'd have 1/2 du. It's going to equal that 2x cubed plus 3x dx. So I have the top part, I have the bottom part, and this just becomes 1/2 integral 1 over u du, which is what then? Okay, so it's 1/2 natural log of the absolute value of x to the fourth plus 3x squared. And to be honest, we don't really need the absolute values because that can never be negative. So that's it. Turn it up a little bit. X to the fourth plus 3x squared. Okay. So when you see something like that, don't panic. It's probably going to take u as the denominator, and then the derivative is going to be that numerator. Okay. Let's try next one. Okay. Yeah. Now, as much fun as those are, and I think they are a lot of fun, that you get this natural log coming out of this. We're going to do some based on integrals of logs. For example, the antiderivative of log base 2 of x. So we have those other two rules. They're kind of the forgotten rules. They don't get to be played with as much. It's like one's Buzz Lightyear and these others are Woody. But you know what's really sad is like Woody was the #1 toy, and then it was like the other ones were like the third or fourth choice toys. They never got any attention. Like we're sad for Woody, but not Mr. Potato Head. Okay. So this is going to be, the way the rule was, x over the natural log of this base, which is 2, times natural log of x minus 1 plus c. That's it. No big.
Did you say you can't take a natural log of negatives?
You can't do natural log or any kind of log of a negative.
So then how come this doesn't have absolute?
It should. I just didn't write them.
Well,
Unless it says.
It didn't have it on top either. Like in the definition, I guess.
So here, since they didn't have an absolute value there, you would assume that they're all positives. But you're talking about up here?
Yeah, I'm talking about the beginning with the definitions.
Yeah, let's go back to that. Because so in this first case, you could have had a negative, so the answer has to be an absolute value. In the second case, for this to exist, x has to be positive, and same thing here, at x would have to be positive. So it's kind of an unspoken subtlety, and I'm glad you saw that. It's good to talk about it. Yeah. Okay, so here we're doing the integral of log base 3 of x dx. What would that be? That's it. Yeah. Okay. I think we're gonna have enough time for our math joke today. Now we're gonna do the same thing now with limits of integration. So again, you see this, and my first thought was I had to remind myself we're doing the integral, we're doing natural logs. So it's probably something related to that because I wanted to go and turn it into a trig function and mess around with that, but you probably can still get there if you did a trig function on this. But instead, if you said u equals that 1 plus cosine of x, what's the du? Rachel has this derivative of cosine of x down like that.
Oh, now I'm like worried I'm gonna get it wrong.
Don't be worried. You've been saying it right all the time. Negative sine x. Okay, good. And so negative du equals our sine x dx. That's our numerator. This part right here is our negative du. So we'll rewrite this as negative integral of 1 over u du. And let's look at those limits of integration. What is u of 0? That's 1 plus cosine of 0. That's a trick, not a trick question, but it's a tricky one. Anyone know what cosine of 0 is? 1 is good, yeah. This is 1 plus 1, so it gives us 2. How about u of pi over 2? It's 1 plus cosine of pi over 2. What's that going to be? Anyone know what cosine of pi over 2 is? No. I feel like we should play the circle game. 1 plus 0, so it's 1. Okay, so we're going to evaluate this. And we get negative. What's our antiderivative of 1 over u?
Let's look at the absolute value of u plus c.
Well, no plus c this time, but good, because we have limits. Yeah. So it's negative natural log of the absolute value of 1 minus a negative natural log of the absolute value of 2. So here's your next tricky question, not trick question. What is natural log of 1? No? Think about what natural log is saying. You remember what logs say? What do logs produce? Exponents. Bingo. That's the big question we ask when we interview math people.
0.
So e to what power is 1? E to the 0 is 1. Good. So it's -0, double negative makes plus natural log of 2. And then so our answer is natural log of 2. I was watching the show. We finally finished it, and it's so stupid. One of those shows you watch just because you're waiting for it to get over with. Have you ever had that happen?
Is that
Like,
what show?
I tell you, you can't think less of me. It's a show called Good Girls. You seen it? Okay, no, okay. It's on Netflix. We saw it. We watched the first episode, and it was all these 3 different people who had these crises in their lives. So they start by robbing a grocery store, and then everything devolves from there. And then they just get stuck in this world of crime, and they have to, try to work their way out of it. And it ends after 4 seasons, and then they canceled it. So you have a cliffhanger at the end. So my wife and I are like, we'll just make up our ending. This is the ending to me. Okay, so let's do this last one here. Why don't you try the last one? Come up with your U. I was going to say, in it, there's one character who wanted to get a GED. He's like, oh, I know logarithms. The logarithms are exponents. I'm like, oh, she got that one right. But she couldn't pass the GED test. I mean, that's a pretty big concept to know. I doubt the logarithms are on the GED exam. Are they? Anyone know? I could ask Angela. We offer it here. We also offer the high set. It's the high school equivalency exams. Okay, well, you're gonna miss the big joke.
Yeah.
Okay.
It's the joke of one thing. I've waited all semester.
Okay, want me to tell you the joke? Let's do it right now. What is the integral of 1 over cabin d cabin? I thought about changing this up where I could say 1 over u du, where u equals cabin. What do you think it is? Cabin. No, cabin by the sea. There you go. There's your big thing. Tell your friends, they won't get it. Took you this long in taking math before you got that joke. Thank you. Okay, so what do you have for this last problem? Oh, we're going to be done through Ivan. He's gone. Homework wise, I would work on all the way through this and just try to get yourself caught up as much as you can on the weekend if you're not already caught up, doing these the logarithms and exponentials. Okay, so what did you choose for your u here? X to the 6 plus 1. So what's your du? Dx. So it's 1/6 du equals x to the 5th dx. So can someone tell me how you rewrite that integral? Good. And what would that be?
It's just going to be -1, well, -1 over u this way.
Where'd you get the negative?
Because you got to bring the u up, right?
Oh,
okay. No, it's
1/6.
So 1/6 times the natural log absolute value. Plus
Okay. And our U is what?
this is plus 1.
Now, I just put parentheses. Did I break a rule? Did I? Can x to the 6th plus 1 ever be negative if you're using real numbers? You can't. It's always positive. So when it's always positive, you don't have to do the absolute value. The absolute value is in situations where it could have produced a negative in there, or the domain of the original function included negative values. You have to do that. So it's a little bit picky on some of these things. I would probably use the absolute value just to be safe, but just be aware, you may see it sometimes, sometimes not. And it could be people being lazy, or it could be a situation where it's not necessary.